Hi, welcome to TJC Physics. This is continuing on to my series of videos on waves. This is going to be part 4. To start with, you'll see here we have a nice transverse wave moving towards the right. It has a frequency of 2 Hertz and an amplitude of 1 centimeter. Now we've talked about amplitude and we've talked about what wavelength is. Let's talk a little bit more about frequency and period, which are the time characteristics of a wave. So first, let me slow this down a bit so we can see it better. So it's going a little more in slow motion. Now, we talked about what the wavelength is. It's the distance from peak to peak or trough to trough. Basically, the distance where the wave repeats itself, repeats its pattern. So here's what we're going to do. You'll notice that as the wave travels through the window, the peaks pass through. Now I want to try something here. So first thing I'm going to do is try and pause this when a peak is just going through the window. There, that's not bad. And I'm going to add a timer. So here you can see I can just put the notations to show you what the wavelength is and the direction of wave travel. The first thing I would like to do is time how long it takes for one full wave, in other words, for the next peak to come by and go through that window. So I've got my timer set, and in a second I'm going to reset it, and I'm going to try and time how long it takes for this second peak to go through. So here we go. I'm going to start the timer. Now, I should have let it go just a tiny bit more, but this is imprecise. But you can basically see it's at about 0.47, or if I had let it go just a little further, it'd be about 0.5 seconds. So the time for that one wavelength to go through is called the period of the wave. Its symbol is capital T, and it's measured in seconds. And this is the time it takes for one wavelength or one wave to pass through a point in space. So the period here is 0.5 seconds. Okay, let us look at another property. This time we're going to look at frequency. So I'm going to stop it right here as it's going through. Okay, now my goal is I want to see how many of these peaks are going to pass through the window in 1 second. So you'll see here I have 3 peaks. Put in peak 0 is where we're starting from. We have peak 1 and peak 2 both coming in at a speed v. I want to count how many of those go through in 1 second. So I'm going to let the timer run, and I'm only going to pause it when the first peak goes through. So that's one wave gone through. I'll start it again, and then we'll see it stopped at 1 second. So you'll see at 1 second, peak 2 is just going through. That means 2 waves went through in 1 second. This is called the frequency. So the frequency is given by a small letter f, and its unit is the hertz, or the waves per second. Now, notice we had 2 waves go through in 1 second, so the frequency is 2 hertz. And that's what frequency is, the number of waves that pass through a point in 1 second. Now, there is a connection between frequency and period. You'll notice here the frequency is 2 hertz and t was 0.5 seconds. So you might notice a mathematical relationship between them, and that is frequency is 1 over the period. They're the inverse of each other. So frequency and period are intimately related. Period is the time it takes for one wavelength to pass through, and frequency is how many waves pass through in 1 second. Not only that, but there's also a connection between frequency, wavelength, and wave speed. And that is that the wave speed, v, is going to be equal to frequency times wavelength, or wavelength divided by the period. This is a common equation for all waves, including light waves. So the speed of the wave is actually related to the frequency and its wavelength. So with this, we now have an idea of the quantities we're going to be using when we talk about waves and solve problems with them. Thank you for watching. Have a great day.